Dear students, for today we'll see what do we mean by semiconductor electronics. Now, in this topic of semiconductor electronics, we are going to see what are semiconductor materials, semiconductor devices, and simple circuits. So, I have divided this topic into various parts, and this is my first part. And in this first part, I'm going to tell you about what is electronics, then what are electrons, then we'll go to see the energy band or diagrams for valence band, conduction band, and based on that, we are going to differentiate the different materials like conductors, insulators, and semiconductors so that we come to a point to understand what is semiconductor. So let's have the first part, which is of your semiconductor electronics, which is the part one. And in this part one, we are going to see what are conductors, insulators, and semiconductors. Okay. Now the flow of this subject, as we are getting introduced for electronics, the flow of this subject will start from what is matter, okay, and then we know that all materials in this world are made up of a smaller unit called as molecules, and all molecules are made up of very basic units called as atom, and atom will have its own atomic structure, and in that atomic structure we will find a component called as electron. Okay, now this electron, the movement of this electron, the electron mechanics, how do you move this electron? What are these electrons going to do? How they move? What is the flow of electrons? The flow of electrons will be called as current. Now that electron mechanics will give you a introduction to the field of electronics. So electronics word is nothing but electron mechanics. Then after we know what is electron, we will see what are their energy levels, and then we will see energy bands. And after you know the energy level and energy bands, we will see a band for valence electrons, that is valence band, and then we will see what is a conduction band. And based on these two definitions, we will differentiate what are conductors, what are insulators, and what are semiconductors. So this will be our flow of study in this part one video today, semiconductors. Okay, so we'll start with what is matter, and as we all know, every matter will be having a smallest unit called as molecule, and then every molecule will be having its smallest basic unit called as atom. Atom will have its own atomic structure, and in that atomic structure you'll be having nucleus, in which you have protons, neutrons, and outside the nucleus you have electrons, and every electron will be in a particular orbit. Then that orbit, that electron will have its own energy level. Then the electrons in the outermost orbit will be called as valence electrons. Then the valence electrons will be possessing a valence energy level. Many atoms together, if you take, it becomes a valence band. And then once external energy is applied, or once the valence electrons, due to some reason of a thermal energy or any other external energy, becomes free, it becomes conduction electrons. Then those conduction energy levels will constitute a conduction band. And then the placing of this valence band and conduction band, how far they are or how close they are or overlapping, that will give you the idea about whether the material is a conductor, insulator, or semiconductor. So that will be our introduction in this first video, because we should know first what is electronics, then we should know the concept of electron, then what are electrons, then we will see the associated energy with electrons, which will be called as energy levels. Then we'll see what are energy bands, and then we'll see what are valence electrons, then we'll see valence band, then we'll see what are free electrons, then we'll see the free or conduction band, and then based on these bands we will differentiate what are conductors, insulators, and semiconductors. Now we'll start the journey of our concept to understand what is electronics and what is semiconductor, what are semiconductor materials, devices, and simple circuits. Now here, basically the first question asked will be what is electronics? So as I've told you earlier, the word electronics is derived from electron mechanics, which means the study of the behavior of electrons under different conditions of applied electric field. Okay. Now here, to understand what is this electron mechanics, which we call as electronics, we should understand what is electrons. To know what is electrons, we should know what is atomic structure. Now, in that atomic structure, we should find out where are the electrons, what are the electrons, what is the energy associated with those electrons. And then, after having a set of atoms, we can make these energy levels as energy bands. And then we can speak about valence band, conduction band. Then we can differentiate material as conductor, insulator, semiconductor. And then we can introduce ourselves to semiconductors. Okay. Now, if you see a basic atomic structure of any atom, you can see that at the center we'll be having a nucleus here. Nucleus will be there. This is called as nucleus. The nucleus will be containing two type of particles. They are protons and neutrons. The protons will be positively charged and neutrons will be neutral. Around the nucleus, you will find these orbits. These are orbits where what are shown. These are electron orbits. Now, in that orbits, you will be having this electrons as particles. So, electrons which are revolving around the nucleus in the orbit will be negatively charged particles. Okay. So, this is a structure of atom. If you see a two-dimensional figure, you can also draw it like this. There will be a center nucleus which will be having protons and neutrons. Around the nucleus, you'll be having orbits, and in this orbits, you will be having negatively charged particles, which are electrons, which are revolving around the nucleus. Okay, so here these are electrons. So here, to have a basic idea about it, in the nucleus, we have protons and neutrons. Out of that, the protons are positively charged particles. And outside the nucleus, there are orbits, the first orbit, second orbit, third orbit. And in these orbits, you have electrons, and electrons are negatively charged particles. Now, naturally, in an atom, the number of protons will be equal to number of electrons. That means the positive charge in the nucleus will be equal to the negative charge outside the nucleus, which is associated with electrons. That means electrically, the atom is neutral. Okay. Afterwards, you can make it as positive charge atom or negative charge atom, but electrically, naturally, it is neutral. Okay. Then, if you see the motion of electrons around the nucleus, so we can see a video over here which can show the motion. So you can see center you have nucleus, and around the nucleus you are getting the electrons which are revolving in the orbits around the nucleus. Okay, so this is the presentation how an atomic structure is existing in nature. Then if you go to study it in detail, so here we can see that basically an atom is having a central field which is called as nucleus, which is at the center. And that nucleus here, as we have shown, this is the nucleus. So we have named it as nucleus. So nucleus will be having two type of particles. They are neutrons. So here you can see neutrons, which are neutral, and you have protons. These are protons, which are positively charged particles. So we have marked this positive sign here. Around the nucleus, you will be having orbit. So one orbit we have shown here for simplicity. So this is an orbit. So this is your orbit, and in this orbit, you will be having electrons revolving. So there are the electrons here, which is signed as negative. They are negative charged particles. This is an important definition for electrons. They are negatively charged particles, and they are going to revolve in a particular orbit around the nucleus. So depending upon the material, depending upon the matter, we can have one, two, three, four orbits, okay, or depending upon their atomic numbers. Okay, so here this is what is the basic theory of an atomic structure. Why we are studying this? We are studying this to understand what are electrons, and then we want to go to see what is valence electrons. And then we will want to see what are valence band, conduction band. And then we want to differentiate between materials like conductors, insulators, and semiconductors. Okay. So here the theory of atom, as we have seen in the diagram, an atom is composed of two regions, the nucleus, which is in the center of the atom and contains of protons and neutrons, and the outer region of the atom, which holds its electrons in orbits around the nucleus. This is a short theory of an atomic structure. We are doing this to understand what is electron first. Then here again we can see, because we have to go to some rules about atomic structure, and those were the rules, those were the postulate which were uh, told along with the atomic structure model, that is the atomic model by the scientist called as Bohr. So according to Bohr atomic model, what are the rules? Okay, so here you can see at the center you have a nucleus, as we have told earlier. So this nucleus will have protons and neutrons. Okay, protons will be positive charged particles. Neutrons will be neutrally charged particles. Okay, they will be neutral. Around the nucleus, this is very important now. There are orbits. These are orbits. This is the first orbit. Okay, this is the second orbit. You can also have third orbit. You can also have fourth orbit, depending upon the material which you're using, depending upon its atomic number. Okay. So here, these orbits will be having electrons. These are electrons which are there in the orbits, and they will remain in their own orbits only. They are stationary in their own orbits only. They will be in their own orbits. Okay. Now here, according to Bohr atomic model theory, okay, according to the postulates of Bohr atomic theory, okay, now here, when the electron is there in the orbit, okay, it is associated with certain energy, and that energy associated with that orbit will be called as energy level. Okay, so energy level of an electron. So this energy level will be that there will be some energy associated with this electrons of the first orbit. There will be energy associated with the electrons in the second orbit. There will be energy associated with the electrons in third orbit. The most important thing here to understand is the energy associated with the electrons of the first orbit will be less as compared to energy associated with electrons of higher orbits. That means here the second orbit electrons will have more energy associated with them. Third orbit electrons will have more energy associated than the second orbit electrons. That way, as you're going outward with the orbits, the energy associated with the electrons will go on increasing. Okay. Now here comes a concept that if an electron, which is in the inner orbit, okay, inner orbit, that is in the lower orbit, if it absorbs energy, if this electron absorbs the energy by some external form, it is going to absorb certain energy, then it can go to the higher level. It can go to the higher level. Similarly, a electron in the higher level, if it releases energy, if it gives out energy, it can come down to lower level. These are the two important things about electrons. Okay, so if electron is absorbing energy, it can go to higher level. If an electron is releasing energy in some or other form, it will come to the lower level. This is what the Bohr atomic model postulates say. Okay, now to see this theory, we will read this Bohr atomic model postulates. This is for our reference so that we can understand the behavior of electrons. The behavior of electrons is very important to understand because we want to know electron mechanics, that is the electronics. And for that, we have to know first what are semiconductors. And for that, we should know what are conductors, insulators, and semiconductors. And for that, we should know the energy associated with the orbits of an atomic model. So, did you understand the flow in which we are going? So, here, according to Bohr atomic theory, this is the most widely used atomic model to describe the atomic structure of element. So the postulates according to this theory is: number one, the electrons inside atoms are placed in discrete orbits called as stationary orbits. Number two, the energy levels of these shells or orbits can be represented via quantum numbers. Number three, electrons can jump to higher level by absorbing energy and move to lower energy levels by losing or emitting its energy. As long as an electron stays in its own stationary orbit, okay, whenever till the energy is staying in its own orbit, there will be no absorption of energy or there will be no emission of energy. Emission and absorption will come when the electron is going to jump from low to high or high to low. Okay. Then number five, electrons revolve around the nucleus in the stationary orbits only. So this is the concept of atomic structure. Now we are studying this because we should know the behavior of electrons. Now here again, when we come to see the orbits and the energy levels, okay, of any atom. So according to your chemistry background, you can see that in an atomic structure, you can have the center, that is the heart, which is the center part of an atomic structure, which is nucleus, which will have protons and neutrons. Out of that, protons will be positively charged particles. So we have marked here as plus. Then around the nucleus, you can have the orbits. This is the first orbit. This is the first orbit. This is the second orbit. This is the third orbit. This is the fourth orbit. And in this orbits, you have electrons moving. Okay, so in these orbits, you have electrons. Now, how many number of electrons you can have in each orbit? So if the first orbit, the name of the first orbit will be K, the name of the second orbit will be L, the name of the third orbit is M, the name of the fourth orbit is N. In the first orbit, we will be having maximum of 2 electrons. In the second orbit, we will be having maximum of 8 electrons. In the third orbit, we'll be having maximum of 18 electrons. And in the fourth orbit, we'll be having maximum of 32 electrons. This is based on the formula of 2n square, where n is the number of the orbit. That means if it is the first orbit, it is 2 into 1 square. If it is the second orbit, it will be 2 into 2 square. If it is the third orbit, it will be 2 into 3 square. If it is the fourth orbit, 2 into 4 square. So here if you see 2 into 1 square, that is 2 into 1 is 2. Then if you do the second orbit, 2 square is 4, 4 into 2 is 8. If you see the third orbit, 3 square is 9, 9 into 2 is 18. If you see the fourth orbit, 4 square is 16, 16 into 2 is 32. So maximum electrons in a particular orbit is given by this formula 2n square, where n is the positional number of the orbit. This is one thing. Second thing is the inner orbit. There is the first orbit will have its own energy level. So here you have seen the energy level. The second orbit will also have its own energy level. The third orbit will have its own energy level. And the fourth orbit will have its own energy level. The energy level will go on increasing from lower to higher orbits. Okay, like this. It is going to increase. The magnitude of the energy will increase from lower to higher level. That means the energy level of the first orbit is lesser than the energy level of second orbit. The energy level of second orbit is lesser than the energy level of third orbit. The energy level of third orbit will be lesser than the energy level of fourth orbit. That means the outermost orbit will be the will have the higher energy level. Now after this, we want to know what are valence electrons. Okay. Now here, if you see an atomic structure, now here if you see any atomic structure, so in that atomic structure, as we have seen earlier, we will be having a nucleus. In that nucleus, you'll be having protons and neutrons, protons and neutrons. And around the nucleus, we'll be having orbits. Okay, so you can have 2 orbits, 3 orbits, 4 orbits, or depending upon the material. Okay, now here, the definition of valence electron says that whichever the last orbit is, that is called as the outermost orbit. The electrons in that outermost orbit of an atom are called as valence electrons. These are called as valence electrons. Now, this is an important thing before we go to study what is a valence band. So here, definition of valence electrons is the electrons, those are present in the outermost shell, that is the outermost orbit of an atom, are called as valence electrons. Clear? Now these valence electrons will be little loosely attached with their nucleus. Now as we have seen earlier, nucleus will be having protons which are positively charged, and the orbits will be having electrons which are negatively charged, and the number of protons will be equal to number of neutrons. So the negative and positive charge attraction will be there. So as a whole, the full arrangement will be set together But the electrons in the outermost orbit, which are called as valence electrons, they will be little loosely attached with the nucleus here, okay, with that atom. Then what do we mean by valence band? Okay, now valence electrons are the electrons in the outermost orbit of an atom. Okay, so if you take one atom, if you take here one atom, you will be having the nucleus, you will be having orbits here. So outermost orbit is having valence electrons. Now the energy associated with this electrons of one atom is called as energy level. If you have another atom, you will be having valence electrons for this atom. Then there are two energy levels. If you have another atom, okay, then again this atom will have its valence electrons. So all these energy levels of these valence electrons of atoms in a set of atoms, if there are many atoms together, the energy levels of every atom, that is the energy associated with the valence electrons, together will be called as valence band. Okay, so here if you see the definition, the electrons that are present in the outermost shell, that is the orbit, are called as valence electrons. These valence electrons are containing a series of energy levels form an energy band which is called as valence band. The valence band is the band having the highest occupied energy. Okay, now here, one theory which is associated with this valence electron, that is electrons in the outermost orbit, is that these electrons, by applying an external force, can come out of the atom, and can become a free electron. Now this free electron can be used for conduction of current. This can be made to flow in certain direction. So you can have a conduction of electron. When that free electron will be called as a conduction electron, and the energy associated with that or with those conduction electrons will be called as conduction band. Now we will come to a concept of what is conduction band. Till here we know what is valence band. Then if you go to see what is conduction band, the valence electrons are so loosely attached to the nucleus that even at room temperature, few of the valence electrons leave the band to be free. These are called as free electrons as they tend to move towards the neighboring atoms. These free electrons are the ones which conduct the current in the conductor, and hence they are known as conduction electrons. The band which contains conduction electrons is known as conduction band. So till here, the important concepts what we have to know is what are electrons, then we should know what are valence electrons, then we should know what is valence band. When the valence electron becomes free electron, it gives you a chance of conduction, it can be allowed to conduct, and that will give you another band of energy which is called as conduction band of energy. Then we will come to the differentiation of insulator, conductors and semiconductors. Now on the basis of valence band and conduction band, we are going to speak about the difference between insulators or conductors and semiconductors. Okay, now here if you see the definition of insulators, insulators are such materials in which the conduction cannot take place. That means there are no free electrons. There is no free electrons for the current to flow, because the flow of electrons only is called as flow of current. Okay, so there are no free electrons, there are no conduction electrons. That means there is no flow of current in this type of material because of the large forbidden energy gap between valence band and conduction band. The valence electrons which are in the outermost orbit of such materials are very tightly attached to the atom. They cannot become free. Okay, so the examples of this type of materials are wood, rubber, plastic or glass. Okay, so that is why you can see these materials are not used for flow of current. The current will not flow through them. So if you see the energy band diagram of insulators, you can see the energy levels of various valence electrons in the atom, which will make the valence band here. You can see this valence band will be full of valence electrons. That is, all the atoms will have their outermost electrons in the outermost orbit, electrons in the outermost orbit intact with that atom. They cannot become free. They will not come out with any amount of external energy applied to it. So that we say there is a large energy gap so that these electrons cannot become free. They cannot become free and they cannot become conduction electrons. So here the conduction band will be empty of electrons. Valence band will be full of electrons. And this will not support flow of current. Flow of electrons will not take place because you don't have any free electrons. So if you see the characteristics of insulators, the forbidden energy gap between the valence band and conduction band is very large. Valence band electrons are bound tightly with the atoms. The value of forbidden energy gap for an insulator will be of 10 electron volt. The resistivity of an insulator, that is the amount of opposition to the flow of electron, that is the amount of opposition to the flow of current, will be in the order of 10 to the power of 11 to 10 to the power of 19 ohm meter. Okay, that is the resistivity. Or conductors are such materials in which the forbidden energy gap disappears as the valence band and conduction band become very close, that they overlap. Okay, for example, copper and aluminum. So here the valence band, that is the valence electrons, can easily become free electrons, and you get many of such excess free electrons which help current to flow in this type of materials. These are conductors. So here if you see the energy band diagram of conductor, you can see that the valence band, which is having the valence electrons, is overlapping with the conduction band. That means a very small energy, if it is given, also many of these valence electrons will become free electrons. And here there are many free electrons which are existing, and the conduction band is also filled with electrons. Okay, so here the flow of electrons is very easy because there are many free electrons available, there are many excess electrons available, and you can make easily a current to flow through these materials. For example, will be your metals like aluminum or copper. Then if you see the characteristics of conductors, there exists no forbidden gap between the two bands, valence band and conduction band. The valence band and the conduction band are overlapped. The free electrons available for conduction are plenty. There are many excess free electrons available. A slight increase in voltage will increase the conduction, will increase the number of free electrons. Then we'll come to a concept of semiconductors. Semiconductors are such materials in which the forbidden energy gap is small and the conduction takes place if some external energy is applied. And the most commonly used semiconducting materials are silicon and germanium. These are very important. Now here, if you see this definition of semiconductor, it says that they have a lower forbidden energy gap. That is, the gap between the conduction band and valence band is very small. That means if you apply a certain small energy, valence electron that is in the outermost orbit of an atom can become free and enter the conduction band. That means you can make some excess free electrons very easily. That means you can make a flow of current very easily if you apply a certain energy. That means before applying the certain energy, there will be no much conduction. After applying a certain energy, there will be conduction. That means if it is not been applied with any energy or temperature, if it is at low temperature, it behaves as an insulator. That means if it is applied with a higher temperature or any other form of external energy, it can behave as a conductor. So its resistance to the flow of current, its opposition to the flow of current is in between conductors and insulators. And that is why this type of materials, that is semiconductors, have a great application in our life today. Okay, so they can be used in many applications, and that is why the world of electronics is growing, and that is where we start developing our semiconducting devices, and with those devices we make circuits, and with those circuits we go to make ICs and other things, memories, which are used in day-to-day life. Then if you see the energy band diagram for semiconductor, there is a small gap between the valence band and the conduction band. So here you can see there is a small gap. This is around 1.1 electron volt. And then you have valence electrons here. If you apply a small external energy, these electrons will become free and they can be counted in a conduction band. They are helpful for you to make the flow of energy, flow of current through this type of materials. Okay, if you see the characteristics of semiconductors, the forbidden energy gap is very small. The forbidden gap of germanium is 0.7 electron volt, whereas for silicon it is 1.1 electron volt. A semiconductor actually is neither an insulator nor a good conductor. As the temperature increases, the conductivity of a semiconductor increases. So if you compare the energy band diagrams for insulators, semiconductors, and conductors, as we have seen earlier, for insulator, the energy band diagram is very large. There will be no free electrons at all. So there is no chance of electric current to flow. Whereas if you see for a conductor, the valence band and conduction band overlap each other. There are many free electrons available and current can flow easily here. Okay, easily here. Similarly, in semiconductor, you see a small energy gap as compared to insulator and conductor. There is a small energy gap. That means the valence electrons are there. If you apply a certain external force, they can come into conduction band and they will help you. They will allow you to make a flow of electrons. That is, they will help a flow of current through this type of material. And that is why this type of materials, which come under semiconductors, find a great importance in variety of applications in today's world. Then again, a comparison if you do in a theoretical part, you can see the basis of comparison. First is the meaning. Conductors are the substances that transmit heat or electricity through them, whereas the meaning of semiconductors are such substances or materials that may act as conductor as well as insulators under different conditions are known as semiconductors. If you see the meaning of insulators, insulators are the substance that does not allow heat or electricity to pass through them. If you take the example of conductors, silver and copper, like metals, will come under conductors which allow electric current to flow. If you see the common examples of semiconductors, there's silicon and germanium. If you see the examples of insulators, you can have wood, plastic, glass, rubber, etc. If you see the conductivity, that is amount of current flowing, okay, the amount of free electrons you have, a conductivity of conductors is high, a conductivity of semiconductor is moderate, conductivity of insulator is low. If you see the forbidden energy gap in the energy band diagram for conductors, there is no forbidden energy gap. The valence band overlaps with the conduction band. For semiconductor, the forbidden energy gap is very small, of around 1 electron volt. And for insulators, that conduction band and valence band between them, there is a large forbidden energy gap. If you speak about resistivity, that in turn, which will give you the resistance, that opposition to the flow of current. For conductors, the resistivity is low. For semiconductor, it is moderate. And for insulators, it is very high. Thank you, students.